All right, guys, here's page 2 of these notes from, let's see the front side, 1-7, function notation and intersections, okay? On page 2 here, we're trying to determine the approximate solution between these two functions, right? So this is just y equals y. Justify your solution is the best approximation given in the table. So the first thing I'd want you to do is just to plug each of these in to x for both of these equations. Like 6 times 2.5 is 15, minus 4 is 11. You could just plug them right into your calculator, right? So literally you'd go like 6 times 3.5 minus 4, and you get 17. And you start to see a pattern here. When you plug in 4.5, you get 23. You can see it just keeps going up by 6. That's because the slope is 6 here. So yeah, you can kind of see the pattern without plugging everything in. Works out like that, okay? You do the same thing over here. Plug in 2.5, you get 5 times 2.5 is 12.5, plus 2 is 14.5. 3.5 times 5 is 17.5, plus 2 is 19.5. And you guessed it, the slope is 5. It's going to keep going up by 5s. Okay, now from there, what I want you to notice is where is their point of intersection? Where is the solution to this? If you look at any two graphs, okay, I've got an x and a y. Let's say I've got one graph that kind of comes up like this, and I got another graph that kind of comes up like this. Their solution right there, solution, is the point of intersection. Now, after the point of intersection, see, look at this one. The y values on this are higher, higher, higher. Then all of a sudden, once they cross the point of intersection, the other graph's y values are higher. So after a point of intersection, they change which one's higher and which one's lower. And that's significant because this one is greater than, and then that's greater than, and it's greater than, and it's greater than, and suddenly right here, it becomes less than. And it keeps going on that. So somewhere in between these 2 points, and what I'm trying to do, again, when I'm saying greater than, 14.5 is greater than 11, 19.5 is greater than, then suddenly 35 is greater than 34.5, which means somewhere in between those two values, in between 6.5 and 5.5, is our solution. So I would have probably said, I don't know, they're so close that maybe like 5.8, or really anything between 5.5 and 6.5 would be an acceptable answer in terms of an approximation, okay? Now, how do we check this on intersection in a calculator? It's really easy, ladies and gentlemen. You're going to go like this, and I'm going to show you the calculator here at the same time, okay? We are going to press second trace 5, enter, enter, enter. Okay, so watch this, okay? I'm going to, first of all, I need to graph these. So let's go to y equals, so maybe I should put that first. Graph. Then do all that. So I've got my graph here. I've got 6x, oops, I need you to see this. 6x, x is this little button next to the alpha button where it says x, so x, okay, minus 4, that's our first equation. The other equation, again, I'm just getting them from right here, is 5x plus 2, and I'm going to graph them. Okay, so I pressed y equals to get my equations, and I pressed graph to get graph. We've done this before, hopefully you remember this. Okay, so again, y equals to put in functions, graph, so maybe I should circle, put squares on, graph to get graphs. Okay. Excuse me. So I've got these points here. I'm just going to check my window. Right here, the window. Actually, I don't even need this. Watch. If I go second, trace, that's this button that says trace, you'll see you get an option that says calculate. We want to calculate the point of intersection. So I'm going to press 5. So you've got second trace 5. And what it does is it puts me on the two lines, and then it says to guess. So I'm just going to press enter 3 times. Enter for the first curve, enter for the second curve, and a guess, which is stupid. I don't know why they even have that option. And just press enter again. And it tells me the intersection is at 632. So let me come back here. Using the intersection key on our calculator, which is what we just did, we found the point to be 632. Which, look, that makes a lot of sense according to what our chart says. Between 5.5 and 6.5, and the value was somewhere between 29.5 and 34.5, somewhere in there. So makes sense, right? All right. So what I want you to do, excuse me, is to press pause to find these data values. So again, you're going to have x squared minus 5 in here, and you're going to plug in -3, -2, 1, 0. This doesn't work the same as the problem up above because there's not a slope. It's an x squared function. Same thing with 3x cubed plus 7, and you're going to plug each of these values in there. I'll get you started. So for this value, I would go -3 squared minus 5. -3 squared is 9, minus 5 is 4. Okay. Same thing over here. I'm going to plug -3 in to this function for this value. So I've got 3 times -3 cubed plus 7. 3 times -27 plus 7 is -81 plus 7, which is -74. I'm not even asking you to do that by hand. Plug it into your calculator as 3 times -3 to the third power plus 7, and it'll spit out -74 for you, especially if you use parentheses. I worry if you plug this in without parentheses, it will tell you -14, and that's not right because it would do the squared before the negative. You got to use parentheses here. So go ahead and fill in the rest of these. Press pause, fill in the rest of these values. I want to make sure you understand how to do it, and then come back and double check your answers. Again, press pause now. They kind of change in value, right? They're getting lower, lower. This must be kind of where the minimum would be, which of course it is for that function. It's x squared, it's a parabola. This one goes a little bit weird. But you can see this is constantly increasing. And that's the way x cubed functions work. So again, I want to start saying, where is it? This function right here is obviously greater than that function. This is still -1 is greater than -17. But over here, they switch signs. So again, somewhere in between there, in between those values, it switches signs, then that means that there was a point of intersection somewhere in there. But then they cross again, which makes sense. Let me show you what this looks like. So this is greater than, this is greater than, and this is greater than. Actually, I guess they don't, because this graph would look something kind of like this and like this. So here's the point of intersection, somewhere in between here. In between here, so again, I'm going to guess like -1.5, I don't know, somewhere between those two numbers, -3, something like that. But I wasn't even asking you to guess on this. I'm asking you to check using your intersect key, which again is done as pressing second. You got to put the graphs in first. Okay, so graph y equals, do the y equals, put them in. I'll show you how to do this. Second, trace, which is up at the top of the calculator. 5, enter 3 times. Okay. Let me show you. Go back to my graph here. Y equals, I'm going to clear those out. I got my first function is x squared minus 5. Be careful not to press, so I just went x squared minus 5. Be careful not to press this for minus. It'll say -5, and that'll throw everything off. The next one, I've got 3x to the third power. We got to do this little button here to get to the third power. And then plus 7 equals, and then I'm going to press the graph button again, y equals, and then the graph button. It graphs it for me. Okay. Now the window, if you can't see it on here, you might have to go to window. I'm just going to adjust this real quick. Go to window and just try from -10 to 10. Scale by 1. This is really where the calculator should be. -10 to 10, scale by 1. I'm going to go graph it again. You can see it just about the same. It's just moved it over a little bit. You can see that point of intersection there between -1 and -2, and it looks like right about -3, so I probably had a pretty good guess. But we can find it exactly by, again, doing second trace 5, enter, enter, enter. Watch, I've got this here, this easy. Second trace 5. You didn't see me press 5, but I pressed 5 for intersection. Enter, enter, enter. 1, 2, 3. And it gives me the point. It takes a second. And it gives me the point. Maybe it's still working. There we go. It's a lot of decimal places. I don't need you to write all the decimal places. I'm just going to write a few here. -1.48, comma, negative 2.798, I guess that's negative 2.8. Okay, we'll just write it like that, negative 2.8. So this was the exact value of their point of intersection, and that's what I'm looking for you to do. The next page is really your homework. When you're done with these notes, you're going to grab this homework from the teacher, from the sub, excuse me. And again, what is it asking you to do here? It's asking you here to just estimate it, so just find those points of intersection. Just find those points of intersection. I put one there, and put one there. And label where about they are. Okay. Down at the bottom, this might help between linear and quadratic, between exponential and quadratic. I don't know why that's there, by the way. And then between exponential and linear. If you don't remember what's what, the linear looks like a line. This parabola here is the quadratic. Maybe put it on both sides. And this one is the exponential one. Okay, just so I can label those accordingly. Okay. All right, so on the next page of the homework, this is just a couple of reminders. This table is just like what we did on page 1 of the notes yesterday, or excuse me, the previous video. Tell me an approximate solution. Okay, I'm not actually looking for, so for an approximate solution between m and x, you gotta do that greater than or less than thing. I'm going to tell you, ladies and gentlemen, there's going to be more than one solution in that problem. Okay, I'm trying to find my solutions. Just a second here. Yeah, there's 2 solutions here. 2 solutions. You can just write where does x equal and where does x equal in terms of about an approximation there. Okay. For this, I want you to use the intersection key, and that's that calculator thing we just got done doing. Okay. So if you don't have a graphing calculator, you might want to start here at number 6 and do these problems first because you need a graphing calculator for that. If they do not cross, then the answer is no solution. Just a hint on one of these problems that might happen. Okay? Help each other out, work through this together, and you're going to be turning this in tomorrow. Have a good day.